This section of my Shiny app is for multi-state modeling, and that is an extension of the Cox proportional hazard model in which we are not only looking at the beginning state and the final outcome, we're also looking at the intermediate steps that are also very informative to that survival process. So we'll begin with for this Shiny app, it will create a data set for you. It'll conduct different types of analyses and produce different figures for you. So we'll first start with creating our multi-state data set, and we do that by going to the Model Builder tab. Right now we're in the multi-state tab, but we're going to have to leave it for a second. We'll enter the data frame that we're going to use, and for this I'm going to use Terry Thurneau's myeloid data frame. So I've entered it here into the first button for enter the data frame name, and so we'll return back to the multi-state tab, and the data is loaded. Now we're going to enter the transient states, and I'm using I'll use the complete response time, transplant time, relapse time, and now we'll go to step 2, and we want to select a terminal state binary indicator. So we use death, and our terminal state time variable is our follow-up time. In step 4, we'll select the states that we're going to track events, and this is something that we will have cumulative events for these different transient states. We'll just do them all. We'll select an ID variable. It's already selected here. And in step 6, we're going to select the independent time variables. And these are our variables that will remain constant throughout each of these different transitions. For this, it's going to be the treatment group and gender for the sex variable. And just a quick note for in step 2, we have 2 variables that will make up that one time variable for death with binary indicator and our time variable. It will be given the name of our binary indicator. So when this comes out in the data set, look for the column or variable of death. And so we'll go back to step 7, and we will create the multi-state data frame. Since we want to do that, we'll click yes. I have a default name of mdata for all the data frames. And then now we're going to download the data in step 9. Click step 9. I'll find a location for that. I'm just going to put in my temp drive. Okay. And in this step, I also need to include the extension name for the file type, our data. Need to make sure to include that in the file name. I'll click Save. And as I click Save, it's now producing the multi-state data frame. I'll check the temp folder that I specified, and it's here. So at this point, we have set up that multi-state data, created it, and saved it. So now we'll go back to we'll leave this multi-state tab, and we're going to go to the data tab. Now we're going to load this data. So I've clicked it. Okay, now I can go back to the multi-state tab, and in this part I'm going to enter the data frame name in the text input. So now I have my multi-state data loaded. I'm going to start to identify which parts of the survival function are specified for each of these different column names or variable names. So our time start variable is tstart, and that's a default setting. For our time stop variable, it's tstop. And the event variable that we need for that survival function will be event. Our ID variables selected just by it being the next available variable name. So we should have our multi-state data loaded, but now we're going to check the data build. And we see our different transitions going from one state to the next. In the top row, we have the transitions from S0, that is the entry state, and by entry it's when the time that we started for the study. So this is their beginning state, and it transitions. We see how many transitions went from the beginning state to the relapse state, transplant, and so on. And we see the different states, the intermediate states, and those transitions. And our terminal state of death, because it's a terminal state, we don't see transitions from it to other states, but we do see those transitions from other states to the death state. And we also have other attributes that you can look to make sure that the time was coded correctly. I believe in this data set there may be one case where we have identical transplant and relapse, or maybe another state, but you can find that here if you want to make sure that your data, multi-state data, was set up properly. Okay, so now we're going to go to the section on setup a current probability and state Aalen-Johansen survival estimate. For stratify, I use that term pretty loosely in the following sections, just because I don't know if the term group or grouping is better for this, but I'm going to use it interchangeably with grouping. But there is a section that we'll see later in which we can stratify a covariate and have those pooled estimates from it. But here I just want to ask if you want it as the value for all cases, or if you want to have curves for different groups. So we're going to look at two different groups. We're going to look at the treatment group. There are two treatments. We have on the time variable, we have it in days. So 1,440 days equals 48 months. So we're going to look at a restricted mean time of 1440 days. We'll run now that we have those entered, we're going to run the probability and state. And this gives us the estimates on the mean, and standard deviation gives us the number of events and the total n. That's part of the standard survival package output. I added in the lower and upper 95% confidence intervals. There's a section on the influence matrix that you'd want to look at in the survival package. And these 95% confidence intervals are values that I added to the standard survival package output. So we can see different mean times between our different groups here. And now we can test the difference in mean time for the time and state of a two-group strata. Here we're looking at the intervention and control. Again, we're going to look at the restricted mean time of 1,440 days. And after we enter that, we can now just run that test. And this following output that we see indicates that within the death state, we do have a difference between the treatment and control state. So in step 11, we can select the primary level, and by that I mean which is our group of interest, and it will sort this data accordingly to that. So I switch it to B. Now we see on the far left, we see the values that line up first are for treatment B. And we can move it back to treatment A. So as we switch between primary groups, we would see the difference values going from negative to positive just because of which group we placed first in those calculations. So now we can go into the probability and state curves. Again, in step 14 we can stratify. We're interested in the treatment effects, so we're going to click yes. For this section, we can select the state colors for our curves. And at the top, I have I list Terry Thurno's 2018 article, which is an excellent introduction and a very thorough study on multi-state modeling that really gives you a good idea of what you can do with this type of analysis. And so I'm using a similar data set, not the exact data he has, but it's on the same topic, and it uses much of the same data. And so I'm going to use also the same colors that he listed. So I'm going to use gray, and this would be for the first state that I listed, and the state that I listed going back to the very top is going to be in this order: complete response, remission, in other words, remission, transplant time, and relapse time. So how it's going to be displayed in the curves, my later state space figure, and the colors are going to go into that order with death at the very last color that's going to be listed. So we have gray, green. In his article, he doesn't cover transplants, so I'm just going to use cyan. And you can see the different options that you have here. And we'll use red and black. We have the option of excluding a state. I'll consider that later. And we have different options with the lower x, upper x, lower y, and upper y axis limits. And we can include a label on the x-axis to indicate how many, in this case, days, and how we will label that x-axis. So I'll use 0. I'm just going to go by every 360 days. Because this is so long, I'm just going to type in those values here. And at 48 months, we would use 1440 for our days. Okay. We'll run the probability of state curves. We see them here. We see a few things about this display that we want to change. First, we're going to move the legend from the bottom right to the top right. This gray line indicates the entry state. It's usually not a primary interest in our analysis. So we see that people leave that state rather quickly. So we're going to exclude our entry state. We have a lot of white space at the top, so we're going to go ahead and change our y-axis limit, the upper limit. Try 0.7. That looks about right. We'll use a restricted mean time. We've used that in the past, so we'll go ahead and use 1440 as our upper x-axis limit. Okay. And I think that's about right. We'll see if we can move over the text values, the text labels, over to the right a little bit. Makes it a little easier to look at. Okay, so at this point, if you want to save this figure, you can, but just by clicking copy image. Now we'll go to a Cox type specific multi-state model. And why we call it type specific is that we will look at different models for each transition. We can, if we consider certain variables more clinically relevant for certain transitions, we can specify that, or if we think a baseline model with the same variables is suitable for each transition, we can do that as well. So we'll start that way. So again, we're going to start with our time start variable, t_start, and this t_start was created in that multi-state data creation process. So t_start wasn't in the first data set I started off with, but it was created while I made that multi-state data. So you'll always see t_start for the time start variable, as well as t_stop, event in step 3, and ID just automatically popped up to the top for our ID variable. So we have predictors of our treatment group, our sex indicator, and suppose I wanted to stratify on sex rather than enter it as a separate indicator that I would want to get coefficients on. I can just add strata. In this section, in the multi-state tab, it uses the survival package exclusively. In the RMS package, your strata wrapper would be strat. So just make sure to use strata because we are using the survival package. And if I wanted to use this modified formula, I would click on yes here in section or in number 7 where I use the updated model formula. But suppose that I wanted to do a different transition specific formula where maybe we think a certain predictor is more important for our transitions to the death state. or to a transplant state, then we can specify that here. I would use a formula similar to this one above in the example code. We can see that there is a list wrapper, and this section, this part of the formula would be our baseline formula, and any changes here would give us that transition specific formula. And for that, the 1:2 plus 2:3, that indicates those specific transitions from the first state to the second state and the second state to the third state. So for those two transitions, 1 to 2 and 2 to 3, that formula would get implemented there. And we can make any other combination of transition and transition specific covariates. And then we would just enter that into here. And then after we enter that, we would click on yes to use the transition specific formula, but we're not going to do that for this example. In step 10, we can indicate yes to begin our model. And we see the output for each of the relevant transitions. Each of the transitions that we have data for, in other words. And towards the bottom, we have a map that shows us the different transitions. This is for your own use if you want to review more of your output. Again, you'll have the option of saving the data. After you began the model, you could enter the data frame name, and then you can click to download. We'll just go back and save this into the temp file again. And again, we'll want to add the RData extension. And it's saved there. And then if we want to review our data later, the current state map and the transitions may be useful. And these are a list of the coefficients that we had in the model. Treatment B, that is the treatment variable, and the level is B, that would be the coefficient. A would be our baseline, and sex M, male is our coefficient, and female is our baseline. We can also look at Schoenfeld residuals. We'll just click yes. If there's something that we're interested in, maybe the p-value for the treatment indicator between transition 4 to 3, maybe that's an interest to us. We can, if we want to examine those residuals further, we can select that and view our plot here. So now we want to summarize our output. We're going to use a state space figure. We'll select, in this we can get just basically a cleaner or briefer view of what we had in our model output, and I just want to look at a couple of indicators. I only have the option of looking at 1 or 2. For this, we have 2 indicators for treatment B and male gender. But if I was looking at age, I can go and I wanted to know what the effect is for a 10-year increase. I could change that to 10 here, and in the output that I would get the coefficients and the estimates would be in increments of 10. But since it's just a binary indicator, we're going to keep that at 1, and I did enter 2 X levels, and I'll run the model summary now. I left steps 2 for each of our covariate levels. I left it blank by default. When I do this, it's going to give me output for all those transitions. But if I wanted to look at only the first 2 transitions, I can just do that 1 to 2 and 3 to 2. So that the map that I showed you above, that's when this becomes helpful. It starts to give you an idea of what are the transitions, and you can find the transitions that are associated with those numbers. But if we're only interested in these 2 transitions, we can leave them here, include them here, or leave it blank to get all transitions, and we're going to do that first. So let's run the model summary. And we see our output that we had before, but just summarized here. And we can see which of these, if we wanted to know which transitions were significant or had a p-value less than 0.05, we would see it here. We have that for the first transition. The plus sign indicates that it's at the p-value is less than 0.10. So, but since we're interested in specific transitions that are more clinically relevant to our interests, we're going to look at a certain set of these transitions. And when we look at the effect of male gender, we're going to look at those same transitions as well. So let's go back up. We're going to turn this to no for now, and then we're going to also turn this to no for now. It's not necessary, but if you have a big data set, you'd probably want to turn this to no so that it doesn't try to recreate your values for you in each step. If you have a big data set, that could slow you down. Okay, so we are going to look at transitions 1 to 2, let's see, 2 to 5, 1 to 5, 3 to 5, 4 to 5, okay, and we'll do the same for our second variable. And we'll run the model summary. Okay, and so we have the same output, but now we just have it for the specific transitions we're interested in. And so now we'll create a state space diagram. We have to select our colors for our states and lines, and we're going to use the same combination we had earlier in the curves. Okay, so our plot layout, that is how the state space figure is set up. Because we have 3 values, we're expecting to see 3 rows of boxes, and those boxes are our state spaces. And then so I'm not going to modify it for right now. And we're going to create this state space figure. And this is a matrix that we used that would indicate how we're going to make each arrow travel between states. A value of 1 would indicate a straight line, and values above or below 1 would determine the curvature of the line, depending on which direction it's going, from left to right or right to left. A value of above 1 would indicate something different for those two possibilities. We'll leave all of these values of 1 as 1 at this point. So we'll close it. You can modify it, and after you modify it, you can close it. And we see the state space figure. Because we only selected specific transitions, we don't have all of these lines connected. Or, I'm sorry, all of these boxes or states connected, but we can add that in later. So this plot layout is the 1, 3, 1 that we see above. We have 1 state on the top row, 3 states in the middle row, and again 1 state in the bottom row. So let's click that to know. So if we wanted, say if we wanted a layout of 3 rows, but in which we have 2 states in the middle row and 2 states at the bottom row, we can change our default, and we would indicate that we modified it in step 3, and we would click yes. The matrix for the arrows pops up. We're going to close that. So if this feels more appropriate visually, then this is an option that we have. We can create various other state spaces. And so in our legend, we see that we have the first variable, which is our treatment, and we see that treatment B for each state is going to be a value that's listed on the top, or listed first, and then for our second indicator, those values are going to come up in parentheses. We'll see that in a second. But we can move our legend if we want to put it to the top right. The matrix comes up, we close that, and then move to the top right. We'll put it back to the bottom right. And it goes right back to the bottom right. So let's change that, the answer for number 5, to no. We're going to modify it. We're going to change it back to the original layout. Change that to no since we're going back to the original. Okay, so you'll notice that there is a plus sign or a indicator for our interactive shiny plot. So if I left click on this point, a value will pop up wherever I click at. And so if we scroll back up to our summary, we see that we have 10 values. So at this point, I think I'm going to trim it down, because that's 10 points that I'm going to have to put on the graph. So I'm actually really only interested in 5 of these. 3 transitions from the treatment variable and 2 from the sex variable. So let me click no on the model summary, and now I'm going to take out the states I don't actually want, or that I don't want to highlight. And I'll do the same for the second indicator. Rerun the model summary. These are just the transitions I want to highlight. So those values are stored. And at this point I'm going to I want to take a look at that state space figure to see how it's set up. So I'll modify these values and I'll add arrows. I want a curve for this transition, so I'm adding in 0.75. I will want to add a curved line. 1.25, 0.75 in this spot. I'll add the line by adding a value of 1. I'll do the same here. And I'll add one more line. Okay, so close that now. So this is what our final diagram will look like. I will actually have to modify this again later, but at this point, if you wanted to take out this diagram, maybe put it in a PowerPoint or Word document, you can copy the image there and do that now. But maybe one of the most helpful features that I have here is that you can point and click, because if you're to do this through code, you'd have to use 0 through 1 coordinates for the x and y axes. And so that just takes a lot of repetition, a lot of trial and error to get the values exactly where you want to. So pointing and clicking is a lot faster. So what I found really helpful is just to use a screenshot, because I know I will make 5 clicks, and so I have in this spot in my screenshot I can put down a value of 1 in this location, 2, 3, 4 here, and 5 here, and I can use that to have as a guide so that I don't have to do this over and over again. So let's begin. Click here for 1. I'll have to do this repeatedly, where I'll have to close the box. I just want to make sure I'm going to put 2 in the right spot. 2 is here. And you'll notice some of these numbers look blurred, and that's just because I have all 5 values kind of stacked on each other at this point. As I click more, those values will become more clear, and once I get them all those values will look clear. 3 goes here. 4 is about right here. And 5 is about here. So at this point I can re-enter my values that I had earlier so that I can get my line, add my lines, and add the curves the way I had it earlier. So I'm adding back those values. I think you should be able to see the matrix box that I'm editing. In case you don't, I'm looking at a box that has, it's a 5x5 matrix with each of the states for the entry, complete response time, transplant time, relapse time, and death time. And so for each time I modify that state space figure, the box pops up and I close it after each entry. Just in case that is not showing up on this video, that's what I'm doing during these different steps. So I'm going to check to make sure I have everything entered correctly. First row looks okay. Second row is fine. Third, fourth, and fifth rows look fine. And you'll notice that in the death state they're all zeros, and that just indicates that there are no arrows or curves leaving the death state since it is a terminal state. So close the box, and there we have it. We have our state space figure now, and we have our key transitions listed. And you'll notice that each of these arrows each color represents the transition, or the state that it's making a transition to. And we can see that we went from creating the data, getting the mean time, the restricted mean time and state, as well as a z-test between two groups on the amount of the mean time and state, and our probability and state curves, and our Cox type specific multi-state model with output, Schoenfeld residuals, and a summary of our output that we use to create our state space figure. And that's it.